Hi ladies, in this video we're going to go through the solutions for your Year 9 Linear Relations test. So you probably didn't get every single question wrong, so it's probably a good idea maybe just to fast forward to the questions that you got incorrect and you need to know how to answer them. But for those questions that you could do, you can skip them, but if you like you can listen to the whole video because sometimes it's always important to learn. Okay, so question 1, we're finding the rule from the table below, from the values in the table below. So we've got our x values here and our y values, and we read the columns as our coordinates. So one coordinate is -1, 4. Another coordinate is 0, 2. And another coordinate is 1, 0. So what we actually have from these three coordinates is actually telling us that this is your y-intercept, because remember when x is 0, you got your y-intercept, and then when y equals 0, this is your x-intercept. So we actually, from these 3 points, know already our x-intercept and our y-intercept. So in our rule, that's given us our constant value. So our y-intercept is our constant value, which is 2. Now to find the gradient, we just want the difference between two y values, our rise, over the difference between two x values, our run. Now what you label as x1 and y1, it doesn't matter. So you've got 3 points here. You can call any of those points x1, y1, and any of those points x2, y2. It doesn't matter. I'm just going to use 0, 2, and 1, 0 because I personally think they're the easiest ones to do. So I'm going to call that one x1, y1, x2, y2. But you could easily use this point if you wanted to. All right, so now we just substitute those values into the formula. So y2 is 0, y1 is 2, x2 is 1, and x1 is 0. So I'm going to have -2 over 1. So your gradient is -2. So the equation is y equals -2x plus your y-intercept, which is 2. So you can see the answer over there. All right, let's do question 2. All right, so we've got an equation, 3x plus 5y equals 14. And it says complete the coordinates for this point. So we've got already the x coordinate, so we know x equals -2. So all we have to do is find what y is equal to. So what is y equal to when x is equal to -2? And we need to substitute that into the equation. So we've got 3. Instead of x, I'm going to write -2 plus 5y equals 14. And then we're just solving for y. So 3 times -2 is -6 plus 5y equals 14. Getting rid of that 6 by adding 6 to both sides. And then we're left with 5y equals 14 plus 6, which is 20. Divide both sides by 5. So y is equal to 4. So you can see here, your y coordinate is 4 when x is equal to -2. All right, let's scroll on to question 3. So this line has, now we've got a vertical line going through the x-axis. All vertical lines only cross the x-axis unless they're lying on top of the y-axis. So this one here has an x-intercept, no y-intercept, and it's going through the point 5, and it has no y-intercept. So it's only going to cross the x-axis. All right, question 4, y equals x plus 5. What is the x-intercept? So we can read straight from an equation what the y-intercept is, which is the constant term. So in this case, the y-intercept is 5, but it's asking us what is the x-intercept? Okay, so our equation is y equals x plus 5. Your x-intercept is when y is equal to 0. So I'm just going to substitute in y equals 0 there. and then I just solve for x. So I'm going to, that should be a plus, take away 5 from both sides, so that 5 is eliminated, and then x is equal to -5. So you can see here that your x-intercept is -5. All right, question number 5. Sorry, just changing colors. All right, we've got 4x plus y equals 20. And we have to find the y-intercept. So we can only read the y-intercept from an equation when it's in the form y equals mx plus c. At the moment, it's not in that form, so I must rearrange to get it into y equals mx plus c. So I can see the 4x here, so I'm just going to take away 4x from both sides. So that disappears, and then I've got y equals -4x plus 20. And now I can read the gradient and the y-intercept. So for the y-intercept, it is 20. All right, question 6. We've got a graph, and this line passes through 7, 3. So you can see 7, 3. What is the gradient of the line? Now this question, you got to use that 0.73. All right, so question 6. We've got to use the 0.73, and we can also see it goes through the origin, which is 0, 0. So just like we used before, the gradient formula, I'm going to allocate x1, y1, x2, y2, and just write down my gradient formula. All right, so my value of y2 is 0, y1 is 3, x2 is 0, x1 is 7. So we're going to have -3 over -7, and then 2 negatives gives you a positive. And you can also see that it's a positive gradient. So if you had a negative answer, you should always just double check with your graph to make sure it's negative or positive. So our answer is positive and the graph is positive, so we're right. All right, question 7, the gradient of the x-axis. So I might just draw you to show you what the x-axis is. Okay, so that is our y-axis. Our y-axis is the vertical one, and our x-axis is the horizontal line. Now, any horizontal line, and that includes your x-axis, so that's horizontal, has a gradient is equal to 0. If it was the y-axis, that's when it would be undefined. All right, question 8. Which of the following lines has a gradient of -1 on 5? So first of all, A is a positive gradient, so we don't even have to worry about working that out. B is negative, C is positive, so we can eliminate that. So I know it's between B or D. Now a gradient of, excuse me, just write it down, -1 over 5 means we have a run. If it's going down, we're going down 1 across 5. Okay, so we've got to find the gradient that goes down 1 across 5. Now B goes down 5 across 1, so it's kind of like the opposite. D, we can see it goes down 1 and across 5, so your answer is D. All right, question 9. Fuel consumption for a car traveling at a constant speed, let me just move this, is directly proportional to the distance traveled. A car traveling 60 kilometers uses 7.5 liters of fuel. Let fuel consumed equal F liters and constant distance traveled equal D kilometers. So we've got a formula that is D equals something F. So we're just working out that gradient, or another name for the gradient is the rate. So basically we want to know how many kilometers we get per litre. So I know that we get 60 kilometers for 77.5 litres. Okay, so if we want to work out how much we get per litre, we can just do 60 divided by 7.5. And just doing that on the calculator, that gives us 8. So that means we get 8 kilometers per litre. So your rate is 8. So if I put in 1 litre of fuel, I get D equals 8, or the distance is 8 kilometers. 2 litres of fuel, it would be 16, and so on. All right, let's move on to question 10. So Sally is traveling at 65 kilometers per hour, so that's her speed. So we can write that down. Write this as an equation of variation linking distance and time, and hence calculate the time she would take. Let me just keep reading. To travel 208 kilometers. Okay, so I'm just going to write that down so I don't have to do it again. So 208 kilometers. So your distance is equal to, well, 65t. So if t is 1, we've traveled 65 kilometers. If t is 2, we've traveled 130 kilometers. So this gradient, or our rate, is just your speed. Now you may, I don't know, in science use the formula speed equals distance over time. That's kind of like where this has come from. So if we wanted to do distance by itself, we can multiply both sides by time, and we're left with D equals ST, which is basically the same as this formula. It would take Sally, okay, so we need to know how long it would take her to travel 208 kilometers. So 208 equals 65t. So we're just going to divide both sides by 65 and then do that on the calculator. So 208 divided by 65, gives you 3.2. And we're just going to convert that into hours and minutes. So we know the 3 will represent hours, and the 0.2, so we're just going to do 0.2 times 60, because there's 60 minutes in an hour. So 0.2 times 60 gives you 12. So it's going to be 3 hours and 12 minutes. All right, question 11, let me just scroll down. The constant term in the equation 4x plus y equals 4x plus 3. 3 is your constant. Nice, easy question. Oops, word just disappeared on me. Question 12, what is the gradient of this line? So again, just a coefficient of x, which is 8, is your gradient. Which of these lines has a gradient of 2 and a y-intercept of 4? So we've got gradient of 2 here, y-intercept of 4. So your answer is C. Question 14. Note which way the line slopes. The equation of this line is, okay, so first of all, we know it goes through 1, so our y-intercept for both of them is 1, but let's do our gradient. So it's a positive gradient. We don't even have to work out the gradient because this one's positive and this one is negative, so it can only be A. It's the only one that is a positive. But if you wanted to actually work out the gradient, you can see our rise is 3. It's gone from 1 to 4. Okay, so 1 to 4, and our run is 5. So that's where the 3 over 5 has come from. All right, question 15. What is the y-intercept of this line? Goes through the origin, so it's 0. Question 16. The rise between the points is, okay, so we're just going to calculate how far we've gone up. 1, 2, 3, 4. So it's 4. what is the equation of the line going through 0, 6, and 10, 26? Okay, so let's write this one down. All right, this first point you can see, because the x coordinate is 0, your y-intercept is going to be 6. And then all you have to do is calculate your gradient. So let's label it x1, y1, x2, y2, and then we just substitute it into the gradient formula. Let me just change back to black. All right, so y2 is 26. Just making sure that's right. Y1 is 6, y2 is 10, and x2 is 10 and x1 is 0. So we've got 26 minus 6 is 20, and 10 minus 0 is 10. So your gradient is 2. So we've got y equals 2x plus 6. All right, question 18, we've got a graph there. The x and y intercepts of a line are given. What would be the value of y when x is equal to 10? So we need to work out the equation of the line first. So let's just do that. So we've got the points 0, 750 and negative 250, 0. Now I can see that my y-intercept, they've already given it to us, which is nice, is 750. So I just need to work out the gradient now. So let's label the points x1, y1, x2, y2, and use the gradient formula. Now I've written it down a few times, I'm not going to write it down again. Let's just get straight into doing the gradient. So 0 minus 750 over negative 250 minus 0. So we've got negative 750 over negative 250. And looking at my graph, it has to be positive. So yeah, the two negatives are going to cancel out each other. So 750 divided by 250 is 3. So your equation is going to be y equals 3x plus 750. And we want to know y when x is equal to 10. So x is equal to 10, y is equal to 3 times 10. So remember, we're just going to substitute in for x plus 750. So we've got 3 times 10, which is 30, plus 750 gives you 780. All right, question 9. Complete the coordinates of the midpoint of AB. All right, sorry, I just had to pause the video. So we're finding the midpoint of A to B. Now you can read it straight from your graph, but we don't really need to calculate, or we don't need to use a midpoint formula for this, because we can see that the y coordinate is going to be the same for any value on that line. So it's always going to be 3. And it's already calculated the x coordinate for us. But if you had to do that, we just add the 2 points together. So negative 7 plus 4, which is negative 3. Okay, so I'll do that over on this side. So negative 7 plus 4 divided by 2. So that's negative 3 over 2 gives us negative 1.5. So that's where the x coordinate comes from, but the y coordinate is always the same wherever we are on that line. So you don't actually have to calculate the midpoint. All right, question 20. What is the distance from E to F? Okay, you can read that straight from your graph. So I've got 1, 2, 3, 4 units. Question 21. An interval has endpoints negative 17 and negative 8 and negative 3 and 3. Calculate the coordinates of the midpoint. So this is where you would need to actually use the midpoint formula. So I'm going to just write those 2 points down. And I'm going to label them x1, y1 and x2, y2. And your midpoint, remember your midpoint, we have an x and a y. Okay, so this is your x and this is your y. The x comes from adding your two x coordinates together. So we add them together, and because we're finding the halfway point, we divide it by 2. And then we do the same for the y's. Okay, so you're just finding the x coordinate and the y coordinate for your midpoint. All right, so I'm going to substitute the x1, x2 in. So negative 17 plus negative 5 over 2. And y1 is negative 8 plus 3 over 2. So negative 17 minus 5 is negative 22. And then we've got negative 8 plus 3 is negative 5 over 2. So your answer is going to be negative 11 and negative 2.5. And you can see that on the sheet over here. All right, question 22. Let me just scroll up. All right, so we've got an equation y equals 1/3 x plus 4. Select all the lines below that are parallel to the above line. So any lines that are parallel will have the same gradient. Okay, so the gradient here is 1/3. So the first one is 1/3. So you can actually write x over 3 is the same as 1/3 x, because when we multiply, and that's a, oops, it's not a 3, it's an x. Effectively, what we're doing here is there's a multiplication, and when we multiply that, you're going to get x over 3. This second one, x minus 7 on 3, I was just checking whether that was actually the answer. When we've got x minus 7 on 3, you can separate that into 2 separate fractions. So we can have x over 3 minus 7 over 3. Okay, so remember, when you've got the same denominator, you can bring the numerators back. Okay, so x minus 7. So this is the same as what we had here, which is then the same as that. So A and B are parallel. All right, question 23. What is the gradient of all lines perpendicular to the one above? So the gradient is -4. If you've got a line that is perpendicular, so question 23, our gradient is -4. So the gradient of the first line is -4. That means the gradient of your second line, we're going to take the reciprocal. So if you can just imagine that -4 is written as -4 over 1, the reciprocal just means we flip that and we change the sign. So this one is negative, so that means this is going to be positive, and we don't usually write plus 1/4, we just leave it as 1/4. So your answer is 1/4. What is the equation of the line perpendicular to y equals x on 6 that passes through the point -2, 4? So I'm just going to write that down. So it's telling us that the gradient is, the first line is 1/6. That means the gradient of the perpendicular line, just as we did before, we're going to flip it, so it becomes 6. And this line, gradient is positive, so the gradient of the other line is -6. So basically, we got to find an equation, y equals mx plus c, where m is -6. So remember, we're doing a new rule, not the original one. And it's passing through the point -2, 4. So we're going to substitute everything into this equation. So we've got 4, m is -6, x is -2, and c is our y-intercept, which is what we're trying to work out. So I'm just going to solve for c. -6 times -2 is 12. So take away 12 from both sides. And c is -8. So your equation, you can see there, our gradient is -6 and our y-intercept is -8. So already got the negative there, so you just had to write in the number 8. All right, and last question. I keep scrolling up and that keeps going down. So let's see if I can, oh, it's not going to work for me. Let's just leave it. I'm sorry. We'll just scroll here. Okay, question 25. We've got two equations. y equals x plus 7 and y equals x plus b. For these two lines to be parallel, b could be any value. B must be 7 or B must be -7. The constant value or the y-intercept doesn't matter. When lines are parallel, they have the same gradient. So as long as your coefficient of x is the same or the gradient is the same, they're going to be parallel. So it doesn't matter what B is. So B could be any value. All right, girls, catch you later.